Hey everyone, welcome back to Take You Forward. Today we will be doing the last problem on the DP on subsequences series, and I'm definitely sure that after doing 11 problems on DP on subsequences, you can solve any problem that is being given on the DP on subsequences. So today's problem will be a rod cutting problem, and it's the 24th lecture of the ongoing dynamic programming playlist. So what does the problem state? The problem state, you will be given a particular n. So assume over here we take n equal to 5. Okay. And for every length, you'll also be given a price. So let's write the price array as 2, 5, 7, 8, 10. Okay. So this is what the price array looks like. Now the question states you're given n equal to 5, right? So that's the rod length. This is the rod length. Now what you need to do is you need to cut the rod into pieces. Cut the rod into pieces. You can be like, hey Striver, I can cut the 5 rod into a length 1, a length 1, a length 1, a length 1, a length 1. Possible. And for length 1, for length 2, length 3, length 4, length 5. For length 1, the price that you will get in the market is 2. So the pricing that you'll get in the market is 2 for every length of rod, because you will cut the rod into pieces and you'll sell them in the market. So the total price that you'll get in the market is 10. Okay. Can we cut it in some different way? You can be like, yes, driver, I will cut it into a piece of 1, a piece of 2, another piece of 2. And if I cut it into a piece of 1, I'll get a price 2. If I cut it into a piece of 2, I'll get a price 5 and a 5. And the total cost will be 12, which is greater. So in this way, you can actually cut this into several other ways, like 1, 4, probably 2, 3. Then it can be a lot of ways. 1, 2, 2. There can be a lot of ways. So you need to tell me what is the maximum cost that you can get. So this cost, you have to maximize it, and you can try every possible way, and you will see that this is the maximal cost. Even if you take like 2 and a 3, the cost that 2 will give is 5, 3 will give is 7. That is also 12. So the maximum cost that you'll get is 12 again. And this is what the problem states. You have to cut the rod into pieces and you have to sell that in the market. And you have to make sure that the cost that you get from the market is the maximum cost. And you need to print this particular value 12. So now the question is, given n, break it, right? So you might get confused, but just try to think it in the other fashion. Try to think it in the other fashion. What fashion? Can I say this? You have a lot of lengths, because if n is equal to 5, you know the rod lengths are like, the rod lengths can be 1, can be 2, can be 3, can be 4, can be 5. We can have 5 different rod lengths. One of a length 1, one of a length 2, one of a length 3, one of a length 4, and one of a length 5. So can I say, how do you collect rod lengths? Can I write this? Collect rod lengths to make n. And while collecting rod lengths, maximize the price. Can I think the problem in the opposite fashion? Instead of saying break n into pieces of rod and sell, can I say collect rod lengths and make it 10 and make sure it is maximized? It'll be like, yes, Trevor, makes sense. And this problem is quite a less similar to the knapsack kind of problems, where we are given an array with values and weights, and we collect weights and we try to form the n. So this problem now becomes similar, correct? So can I say this for this particular example? Like if I just take this particular example, 2, 5, 7, 8, 10. Can I say this? If I write down the index number 0, 1, 2, 3, 4, I know index 4 means a length 5. I know index 3 means a length 4. I know index 2 means a length 3. I know index 1 means a length 2. I know index 0 means a length 1. So can I solve the problem in a similar way to knapsack? I think I can. So what I'll do is I will try to pick lengths. Try to pick lengths and sum them up to make the given n. This is my funda. I'll try to pick them in various ways. I'll try to pick length in all possible ways. And whenever I say in all possible ways, what comes to your brain? Your brain immediately starts saying, okay, best way is to write recurrence, write recursion rather. And how do you write recurrence? I have taught you that funda. How do you write recurrence? I have clearly stated you. First, express in terms of index. Obviously, you can express in terms of index because you're given an array. You're given an array of rod lengths and prices. So you'll take a rod length. And you're looking to form this particular n. You're looking to form this capital N, which is initially 5. So that's what explore all possibilities. So you know what are the possibilities on DP on subsequences. It's not take and it's take. And it is being given, you have to maximize the price. So maximize the price, maximal of all the possibilities I can say is what you will have to write. So the question is pretty much similar to what we did in unbounded knapsack. Why? Because over here, what are you looking? You're looking to format this particular n, right? And you're trying to maximize all the possibilities. So can I say this? I will start off with index and a capital N. Now 2, 5, 7, 8, 10. This was the pricing of rod lengths. Can I say this? If I'm writing 0, 1, 2, 3, 4. If I'm writing f of 4, which is f of n minus 1, comma a capital N. Can I say this? What I'm asking is, till here, what is the maximal cost that you can format n? Till here, what is the maximal cost that you can format n? Till index 4, what is the maximum price you can obtain? Maximum price you obtain, correct? That is what the question states. So can I say, let's forget about the base case. Can I say, I will be like, okay, I will have a not take case. And if I do not take that rod length, then the value added or the price added will be 0. And I'll move to the previous index and the weight or the n remains same. Now, when can you cut it? Can I say the take? Since I'm looking for maximum pricing, it will be initially intermean, very obvious. And can I say I can only cut, because if I'm looking to form n, that rod length has to be, because if you're coming up with a value as 3 and the rod length is having like something like 3 or 4, so how do you know the rod length? I told you. What is the rod length for this guy? It's 5. What is the rod length for this guy? It's 2, because the rod length is 1, 2, 3, 4, 5. So can I say this? If the rod length, like if I try to write it in a very sophisticated way, can I say the rod length is nothing but index plus 1? Again, makes sense. The rod length is index plus 1 every time. Can I say the rod length has to be lesser than equal to the length that I'm looking for? Makes sense? And if it is, then I can take this rod length and the price added will be price of index plus function of index n minus the rod length, because this much rod length will go off. The rod length will go off. Now question arises, do you stand at the same index? Yes, Baba, yes, you stand at the same index. Why? Because if you carefully remember, you can actually pick up one as many times as you want, which case infinite supply of rods, and whenever there is an infinite supply of rods, what do? I have already taught this in the previous lectures. You stand at the same index, and right at the end of the day, you can return the max of take and not take. That's it. What about the base case? You write the base case. We definitely know the base case will be at index equal to 0, but we need to think on this base case as a single element now. So what is the initial starting? The initial starting that I started was n minus 1. So you will go on 0. So 0 is the base case. Let's just think it as a single element. So we are at the 0th index. We know the rod length for 0th index is 1 and it will have a price. Assume it has a price of 6. And I'm coming up with a rod length. Yes, I'm coming up with a rod length 12. This is the remaining rod length that I'm looking to make. Initially, whatever it is, this is the remaining rod length I'm looking to make. Looking to make this. Because that is what the recurrence was stating, right? Because that is what the recurrence was stating. Till index 4, what is the maximum price you can obtain in order to make n, right? So whatever n comes, if at the last index n is 12, how can you make this 12 is the question. So the question is, how can you make this rod length 12? Because over here, it's a rod length 1. So if you can take 1, 1, 1, 1, dot, 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 1, 12 times, can I say that will make this remaining length 12? Be like, yes, it will. So whatever n is left at the end of the day, at index 0, can I say the pricing will be, because the rod length is 1, I can make that rod length, because if the remaining length is n, it will require n rods of length 1. N rods of length 1 is what it will require. And if it requires n rod of length 1, what will be the price? N into price of 0. Perfect. So that's what you'll return. You will say n into price of 0 is what I'll return. Because the last guy is of length 1. And if it is of length 1, I know I'll require n rods of length 1. And the pricing will be into price of 0. That's the base case. Super simple. So once I've written the base case, what's the next step? It's a recursion code, right? So you have to convert the recursion into memoization. So overlapping subproblems will be there. What's the time complexity of recursion? Obviously not 2 to the power n. It is exponential. It's greater than 2 to the power n. We have already discussed. Why? Because of staying at the same index. You're staying at the same index. We have already discussed this. What is the space complexity? The auxiliary stack space is the recursion depth, and it can go on till big O of target. Whatever target is, because you're taking the target again and again. So big O of target it can go as. If you do memoize index and n, couple of changing parameters. Index is n. N is also n. So n into n plus 1 will do. And the time complexity will be big O of n into n. The space complexity will be big O of n into n plus big O of the target as the auxiliary stack space. And as usual, I'm not a big fan of auxiliary stack spaces. And if I'm not a big fan of auxiliary stack spaces, what do? I convert this into a tabulation code. What are the rules? Rules. Write the base case. Write the two changing parameters. Copy the recurrence. As simple as that. As simple as it can get. Let's write the base case at first. Let's go back to the recurrence. By the way, in order to convert it into a memoization, just make sure you write dp of index n equal to, and over here dp of index n not equal to -1, and you try to return. Simple as that. So let's look at the base case. It states index equal to 0. Does it have a boundary on n? Does it have a boundary on n? And the answer to that is it does not have a boundary on n. So n can be anything. It can be 1, it can be 2, it can be 3, it can be 4. In fact, it can be 0 as well. It can be 5, it can be 6, it can be anything till the largest n. So thereby, I know index is set as 0. So I will be declaring dp of n and n plus 1 for sure. So can I say the value of n can be from 0 to whatever the original n is. Thereby I can write dp of 0, n is nothing but whatever I wrote in the base case, n into price of 0. Perfect. This is the base case. I exactly copy pasted the same thing, but I did it for every n. I did it for every n because n can be anything. Perfect. Superb. What about this? What did you do in the recursion? In the recursion, it went from n minus 1 till 0, where 0 being the base case. What is tabulation? Bottom up. What is tabulation? Bottom up. So from base case, you go till the ultimate. So base case is done. So you start from 1 till n minus 1. What about n? You do it in the opposite. Done. And now you just need to copy the recurrence. So yeah, without actually wasting any time, let's super quickly code this up. So you're given the price and you're given the n, right? So what I can do is I can write the function with index and the capital N, and we can take the vector int and the price. Correct? So that's what I will be taking. Can I say if index is equal to 0, I need to return the n into price of 0. Perfect. And there'll be other cases of not take and take, right? So not take case will be 0 value plus f of index minus 1. You move back to n and take a price. But the take case will be having int, you're looking for maximum, right? So int mean. And what is the rod length? The rod length is nothing but, as of now, at the index, it's index plus 1. So I need to check if the rod length is lesser than the required n. If that's the case, I can definitely take it. And if I take it, it will be price of index plus function of, you stay at the same index, and the rod length that you are looking for will reduce by the rod length. Perfect. And you just pass on the price. And over here, you can return the max of take and not take. And right here, you can say return f of, you start from the last index, which is n minus 1. You look for the n rod length and you pass on the price. So that's what you will have to write. So you see it is giving correct answer. What's the next step? You know, it will be giving you TLE. So please make sure you memorize this. So create a DP array and try to memorize this into n into vector of int n plus 1 comma minus 1. Once you memorize this, this will go as DP. Obviously, this will go as vector int dp. This will be dp of index n. This you can say if dp of index n not equal to minus 1, you can say return dp of index n. Perfect. And just make sure you pass a dp here. Make sure you pass a dp here. Once you've done this, super quickly run this off. It is running. Let's quickly submit this and see if this is running fine. It does give me 100 marks. What's the next step? The next step is to convert this into a tabulation. Step 1, make it 0. Step 2, step 1, write the base cases. It goes from 0, goes on till n plus plus, and you write dp of 0 and the n equal to the base case. Whatever is the base case, just make sure you copy paste. Done. What's the next step? For int index equal to 1, index lesser than n, index plus plus, and you can just go on from for int w equal to, n equal to 0, n goes lesser than n, and you can do capital N plus plus. Just make sure you copy paste this entire stuff. Perfect. Copy paste this entire stuff. Do some tabbing spacing. Okay, cool, done. What's the next step? Over here, instead of f, you write dp of index minus 1. You say this. Just make sure you do this. And over here, what will be this? dp of index. What about this? N minus rod length. Perfect. And over here, you can just remove the return. And over here, instead of this, you can just, you can write the return. Instead of this, you can write the dp, n minus 1, and the n. Perfect. And you can just erase this off. So this is, let me quickly check if this is perfect. This looks perfect to me. Let's quickly run this off. So that's how you write the tabulation. Now let's quickly submit this off. Now it does run. What's the next step? Space optimization. Again, index minus 1, index previous current. Now space optimization is so easy, right? When you started, you were like, oh, bhai sahab, it is so tough. But now it looks easy, isn't it? So vector of int previous n comma at the n plus 1, because a row is what you're taking, cur n plus 1 comma 0. So instead of this, you can be like, let's write previous. Instead of dp of index minus 1, why don't I write previous? Instead of dp of index, why don't I write cur? Instead of dp of index, why don't I write cur? Over here, why don't I do it previous equal to cur? Over here, why don't you do it previous? And I'll quickly run this off. Indeed, it does run. Let's quickly submit this as well. 100. Okay, so this was 2 array space optimization. Can we space optimize this into a 1D array? And the answer to that is yes, we can. Previous video, unbounded knapsack. So over there you saw we were using a state right above, because n is the column number, previous n is the right above, and n minus is like if you're trying to compute this, you're trying to use the previous computed values and this guy and the previous computed values. So these guys have no significance. In the previous column, this guy has, like, the crossed guy have no significance, so there's no need to store it. Whenever you're computing this current, just rewrite over here. Whenever you're computing this current, rewrite over here. Whenever you're computing this current, rewrite over here. Whenever you're computing this current, rewrite over here. Use this, compute this, and try to rewrite over here. That's it. So you can easily use the single one. Yes. So just use the single one. No need to do previous equal to current. No need of this current one, because just rewrite it, because you're using the previous guys and the right above guy. So done. Let's quickly run this off. So 1D array, yeah, single array, and we are able to space optimize this. So guys, DP on subsequences is done. We have done all the patterns on DP on subsequences. Now you tell me in the comment section, can you solve any problem on DP on subsequences now? If you can, please tell me in the comment section, how did you like this DP on subsequences pattern where we solved a bunch of problems? Please do that, because that will highly motivate me. And yes, if you have watched this video till now, we have learned recursion, memoization, tabulation, 2 space optimization, 1 space optimization, and you've understood everything. So just in case you did, please make sure you like this video. And if you're new to this channel, please do consider subscribing to us. And yeah, with this, let's wrap up this video. Let's meet you in the next one. Till then, bye bye, take care.